In this video, we're going to talk a little bit about functions, and we're just going to solve some examples of questions that were asked. Is the following a representation of a function, and if so, what are the dependent and independent variables? So in this first example A here, we're asked, is this a function? And in this case, we have y on the left, and we have everything else with x on the right. If we choose an x value, which means it's the independent variable, choose an x variable, we put it in, we get one value of y, which is the dependent variable, and so yes, it is a function, and it would be y as a function of x. And so in the next example, we can begin by saying, well, if we try to solve this for y, because we have a squared here, we would see a root in our answer most likely, or two different answers. So since there's no way to express this y as a function of x, or y on one side and x on the other side, we're going to say here no, y is not a function of x. If it's not a function, we're not going to worry about the dependent and independent variables. Let's solve it for x, in which case we would get negative 3x equals y minus 4y squared plus 12. Divide everything by minus 3. We get 4 over 3y squared minus 3y over 3 minus 4. So this is solving for x. So now x is a function of y using functional notation, which would mean x is the dependent and y is the independent variable. So is it a function? Not y a function of x like we usually see, but it would be x a function of y. So if we look at the next example, is this a function? And what we're going to look for is p a function of I? So if we choose I negative 2, we get one answer. If we choose 0, we get one answer. 1, we get 1. 5, we get 1. And 11, we get 1. So yes, it's a function. And in this case, the dependent is p and the independent would be I. This would also work the other way. I would also be a function of p. And the table here, the bottom then, D, is I or p a function of I again, we'll check. And the answer in this case, we see negative, or 9 gives us 4, but 9 also gives us negative 7. So for the same I, we get two different answers, which means the answer is no, it's not a function. And there is no such thing as independent and dependent if it's not a function. So determine whether each of the following represents y as a function of x. So if we look at this first one, when we have a graph, we use the vertical line test. So if we can draw any vertical line that cuts twice or more than once, it is not a function. So if we just draw a vertical line, crosses here, not a function. So is it a function? No. Here, if we draw vertical lines anywhere, and I'll just draw a few so you can see, every vertical line touches once. There is no vertical line you can draw that would touch this curve twice, and therefore we say yes, it is a function, y function of x, and over here y function of x. So there's some examples of determining if something's a function and what the dependent and independent variables are. We'll look at some examples in the next video to learn some more about functional notation and how to use that.